All right, example 1, use your graphing calculator to determine which of the given viewing rectangles produces the most appropriate graph of the function f of x equals x squared plus 3. Draw the graph for each one. All right. As far as drawing the graph is concerned, this is going to be a sketch. It's not going to be perfect with graph paper. I want you to draw a rectangle on your paper, and just give me the x min and max, y min and max, and then give me a basic sketch of what the graph looks like on your screen. Again, it doesn't have to be perfect. If we take a look, first of all, it's telling us to graph a function x squared plus 3. So start off going to y equals. You can clear out anything that might be in there. I don't think yours will probably have much of anything, if anything. I played with a couple of these calculators earlier, but most of them should be blank. But if they have anything on them, just get rid of them. You'll notice that next to each one has colors. That's what color graph it'll give you. And you can change those colors. My guess is if you zip over there, you can just hit enter and toggle through different colors if you want. I think blue is fine for the first one. So I'm going to graph x squared plus 3. So I type in x squared plus 3. And once you've got your equation typed in correctly, choose second quit to get out of that menu. And what we have here on this list here is that's the way the books decided to describe the intervals that they want you to graph. And what they're telling you here for part A, these are the x minimum and maximum, these are the y min and max. If we go to our window, which is these buttons along the bottom of the screen, the second button over is window, you'll see that we have x min and max, x scale, y min, y max, y scale. Then we have x resolution and delta x. What this has to do is how often the computer or the calculator itself is going to pick an x. So every 0.0075 is going to pick an x. So what I'm going to do here is I'm going to put in those numbers, -2, and make sure you hit the negative key, not the minus key when you type in a negative number. So -2 to 2. Now, as far as the scale is concerned, that's just, again, it's just going to be a dash at 1, a dash at 2. If I put a scale of 0.5, it'd be 0.51, 1.52. So that's all x scale is. How often is there's going to be a little dot there to represent, you know, the next number. It's not that important when we're doing what we're doing here. Y min and max are already at -2 and 2. I wouldn't worry about any of this stuff down here. The bigger this number is, the less nice the graph is. So a small number is better than a big number there. And the delta x, the smaller that is, the more dots it's going to pick, so it'll make a nicer graph. It seemed like it was doing these automatically, so I'd probably leave that stuff alone. So just focus on these and the x and y scale for now. Hit graph, and it should graph your thing somewhere, and it's missing. Anybody have an idea why that might be nothing? Say again? We did. We put the equation in, so it should graph the equation, x squared plus 3.
It's too big.
What's too big?
A function.
Okay, let's imagine what x squared plus 3 looks like. So if I was just to do this, and don't draw this on your paper, and I just did, here's 1, here's 2, here's -1, here's -2. All right. If I put 0 into this function, what do I get out? 3. If I put 1 or -1 in, I'm going to get 4, right? 1 squared plus 3, 4. I saw the fingers going up. Video doesn't pick up fingers. Anyway, notice that we got x squared, which is a parabola. We can see it's turning upward, and this is what it's going to look like if we were to graph it. And we chose a viewing rectangle right there. -2 to 2, -2 to 2. The graph is above it.
So make it
All right.
like 5 and -5.
Well, maybe. That's what the next thing is. So they're just walking us through it. I just want you to know that if you're going to graph something and you put in a window where the graph doesn't exist, that's what you're going to get on your picture. It's going to happen. And sometimes if you don't know what a graph's supposed to look like before you start doing it, you start playing around with these numbers, you might just happen to pick a region where the graph doesn't exist. It's too high, too low, so it's not where it is. And a lot of times students, in your case, will look at this and say, I don't know how to graph anything. This calculator's not working, that kind of stuff. Just know that the graph exists where it exists. If you tell the calculator to look here, but the graph's up there, it's not going to find it. All right. So as far as part A is concerned here, I'm just going to draw a rectangle on my paper, -2 to 2, negative 2, 2. So I'm putting my x min and max on the left and right, my y min and max on the up and down. I'm going to draw my y-axis and x-axis because that's what's showing up on my screen, and I'm done with part A. Okay. You graph it on your calculator, then you draw a picture of what it looks like on your paper. That's what this problem's about. And again, the whole purpose of this is just to get us accustomed to using our calculators to graph things. Okay, I'm going to keep y equals exactly the same because we're going to keep on graphing x squared plus 3. What I'm changing is the window, so I go back to my window, and now I want to do part B. We're going from negative 4 to 4 on x, negative 4 to 4 on y, so I do that right here. Once I get my x min and max and y min and max good, these numbers still are rather small, so my scale of 1 seems reasonable. Okay, I'll get 4 dashes to the left and right, 4 dashes up and down. That's not ridiculous. I hit graph, and now we can see the very bottom of this parabola. Okay, so we actually got part of the graph on our calculator screen this time, but it's not much of the graph. It's not what we're probably looking for, but we'll continue on. So I draw a second rectangle here, negative 4, 4, negative 4, 4. I draw my x-axis and y-axis in, and the graph is kind of up here. Notice I didn't get a ruler out to measure anything. I just draw basically what the picture looks like on my paper. I could actually cheat on this computer because I can actually drag this over like that, but I'm not going to do that. I'll put myself in your shoes and draw it just like you have to draw it. All right. But again, what I'm looking for in your paper though is what was the x min and max, what was the y min and max, what did the picture on the calculator look like. All right, and that was part B. Okay, moving on to C. Go back to my window. This time we're going negative 10 to 10 on the x-axis and negative 5 to 30 on the y-axis. Now this time notice the numbers are getting a little bit larger, specifically for the y. All right, so 10 dashes left and right on x doesn't seem ridiculous, but 30 dashes up might be pretty bad on the y. So maybe on the y scale I'm going to change that to, let's go a 5 scale. Every dash represents 5, so it's going to be 1 dash down and 6 dashes up. And maybe I could even make my x scale 2, so every dash, so 2, 4, 6, 8, 10, negative 2, negative 4, and so on, like that. So I hit graph, and just to give you a highlight of what I'm talking about with the dashes, instead of going 10 dashes to the right, this is 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, negative 8, negative 10. Sometimes you'll use your calculator to approximate answers, so knowing what those dashes represent helps you to approximate. All right, so like, what would the value be around negative 2? Well, I come up here, it's about right here, and I know that's 5, so 5, 10, it's around 10. Okay? It's actually 7, but it's around 10. So knowing those dashes. That's looking more like what I'm expecting a parabola to look like. So that looks like a pretty decent graph. Again, I want to draw a picture of what I'm doing here. So I draw my rectangle. I've got negative 10 to 10 and negative 5 to 30. This time the x-axis is towards the bottom. The y-axis is right in the middle. And the graph itself kind of goes like so. And then finally we want to graph D, and we see here for the window going negative 50 to 50. Now that's 100 spots, right? So a 2 scale, that's going to be 50, or 25 to the right, 25 to the left. That's a lot. Let's go at a 10 scale there. And negative 100 to 100. I'd probably go at a 10 scale there too, maybe even a 20 scale. And there's the graph. Again, I get a nice looking parabola. Looks reasonable. So if I had to narrow it down to 2 good graphs here, which 2 are the best? C and D would be the best 2 of the 4 we did, right? Went negative 50 to 50 and negative 100 to 100. Between C and D, which one's better?
D.
Okay, I got a vote for D, a vote for C,
To C.
and I got a something backtracking saying C instead of D. Why is C better than D?
It's closer.
Okay, looking at D, can you tell, looking at your calculator screen, that it doesn't touch the origin? Okay, it zoomed out so far that it's lost a little bit of detail. In C, you can see that the graph was above the origin, so it's very obviously not touching 0. This one looks like it almost touches 0. Maybe it does, I can't tell. It's zoomed out so far. So we're looking for detail in our graphs when we're doing this viewing window idea. So that's what I'm looking for on this. Now, a few of your homework problems are going to be like this, where they give you choices, and others will just be figure out a good viewing rectangle. There could be, I've got 8 people, I can get 8 different good answers. Okay, this is really good. The C, I can make it better. I mean, just to show you, if I go back to the -10 to 10, we went at a 2 scale, and -5 to 30 at a 5 scale. There was C again, right? And you can see again, it's very clearly off the origin. It's above the x-axis. How can I make it better?
Zoom in.
Okay. Zooming in to one extent. So 2, 4, 6, 2, 4, 6. You can see that the graph goes off the screen around -6 and 6, right? So I want to get a better, clearer view of even everything going on. If I change from -6 to 6 on the X window, now I've got more of the graph on the screen. It's a little distorted. Okay, you got to understand that the graphs on your calculator will be distorted from what the real graph looks like, depending on what your scale is. If you make a square scale, it'll look exactly the same, because our graph paper we use is 1/4-inch squares. In this case, that's 12 across. This is 35 up and down. That's skewed, so it's going to not look exactly like it would look like on paper. Okay, but just know that you can even make a better graph than they did. But when you get options like this, pick the best option of the 4. I would pick C as my option. That's the best graph. So when the homework problems look like that, graph it in 4 viewing windows. I'm looking for all your graphs drawn, and I want you to make a decision. I think this is the best one. That is a judgment call. If you picked A, I'd probably count it wrong, because I think you're just messing with me. But if you picked C or D here, I wouldn't say either one of those is wrong. C is better than D, but both of those are better than A and B. So I'd say if you pick one of the top 2 obvious ones, they're pretty obvious. The top 2 are pretty obvious. The best one sometimes is up to interpretation of the person. But just know that that's what your homework will look like for the first few